reinventing vehicle infotainment. I was really inspired by the previous talker that mentioned about Google glasses and about the blind people actually moving around in the cities, because that actually gives a purpose to these self-driving cars. Because if you can have self-driving cars, you can, as a blind person, actually be in a car and be transported from A to B. Because I've often wondered, what will I do in the car when the car is driving? And one thing is, of course, that I can play around with all those gadgets. So I will touch three concepts, or three really important factors within the vehicle industry. And that is about safety, and quality, and environment. So before I do that, I want to go back to infotainment. That was explained before, that this kind of traditional things that you have in the car with the FM radio, the DVD player, the navigation system, the ability to connect your mobile phone to make calls. Because even if this is a kind of funny picture, there is actually a reality. This is the workplace of a truck driver today. Is it safe? What do you think? No. So we can talk about safety and security and all these standard organization and how Volvo needs to provide safe and secure cars. But when you look at how the drivers are actually using the environment, their working environment. So safety is a very important aspect when it comes to the vehicle industry, and having well-integrated services running in the vehicle. Another aspect is quality and environment. So quality here means basically that you have uptime, that your vehicles are always running. If you're running a fleet of vehicles, you need to make sure that they are always running. So you need to have uptime. For the environment, you need to look at logistics and having eco-driving concepts built into the cars. And that is what this is all about, reinventing the vehicle infotainment as we see it today and using it as a service platform for any services actually that can make the vehicle safer and bring in more quality and environment aspects to the driver. So, let's go into a concept that we call information of things. I think you have all heard about Internet of Things, and it's even got a definition from Gartner that it's about connecting objects with embedded technology that can communicate with internal states and, of course, with the devices around it. What we like to talk about is actually something that is referred to as information of things, because what we see now is information technology in the cloud. We see a growing number of data services in the cloud, and the cost to move data and store data in the cloud it's really cheap. If you combine that with embedded things that really talk nowadays, we heard about the 4G, and you even have passive radios like NFC that you can build into really small things. So things are really talking, and you have the information technology in the cloud. And if you combine those concepts, we call that information of things, because the value is not created from having products or things talk. The value is when information matters to the business. So I will give you an example on a system that we at Combitech built here. So this is a product. It's an electric car that you can see outside here, and we'll look more into that. It's very nice. It carries 3 persons. It travels at a maximum speed of 45 kilometers per hour. It has a distance of 50 kilometers. And that is really based on the batteries, and that it only weighs 200 kilos. And you only need an AM license, driver's license, which means that you can be 15 and drive your friends around in this within the city. It uses about 4 kilowatts hours per 100 kilometers, which means 0.04 kroner per kilometer, which is kind of inexpensive, but it's not very smart. The instrument cluster looks like this. It's kind of traditional instrument cluster. So what we looked into is how we can make it smart, and of course the definition of smart is varying. But this is what we think is kind of smart. You can integrate some map services, and you can actually get some messaging services, and it can be adopted and customized to the driver. And depending on what solution you choose to build this service on, you can actually get it connected as well. So if you have a connected and a smart product, you can create a product system. So you can offer, for example, rental services. You can have services on the cars. You can find charging stations and so on. And if you have that as a product system instead, you can connect it to other systems. So you get a system of systems providing values to, for example, your local grocery dealer that has a charging station and lets its premium customers charge for free when they're shopping. Or you can have the kind of fleet management services to delivery services, connecting your cars and tracking them and offer different kind of services. So this is an example system that we have built, and I will show it later on here. But of course, this also applies to real products then. So this is an example from Volvo that has different kind of levels in their value chain, ranging from the products that they sell, smart products that actually get some new services to the driver. You can create value by connecting the car as well. But even more important is that when you come into this kind of product system, where you have the aftermarket, the fleet owners, and the body manufacturers benefiting from the connected truck. And the example that we have here is waste management, where Volvo and Combitech and Renova has worked with optimizing waste management, combining different systems. You have the traffic system with traffic information from Trafikverket, the weather, road maintenance, and so on. You have the waste optimization from the production system, the plant usage. You have the different kind of sensor fusion services with autonomy and field sensors, and all that bring it together. You have a system that brings value to the user from the information that you gather from the product and the ability to have it connected. Okay, one thing that is really important to remember here is that these systems are not always connected and not always running. So I really like the analogy of the escalator. What happens to an escalator when it breaks? Yeah, you get stairs. So that's okay, you can get from here up to here. It's not the same service. You have a kind of degradation of service, but still you are able to use it. And that kind of thinking you need to have in your product. You cannot depend on having everything connected always. You have to have some kind of graceful degradation of the systems that the user understands. So this is a really good analogy, I think, with the escalator. So please bring that with you. Okay. So we have talked about the vehicle infotainment and how you can actually use that as a service platform. I've described the concept of information on things, that it's not connecting things that brings value. It's actually the information you can get out and how you use it. And what I will talk about now is how do you choose? How do you create this system? Because there are many different solutions when you build a system, especially within the vehicle industry. I guess it's the same with the home automation. So about 1.5 years ago, we did a study for Volvo, and this is Volvo AB, doing trucks and buses and so on, because they had invested a lot of money into new service platforms in the car, an infotainment system and so on. And they realized that nothing is happening. They still invested a lot in the platform, and their interest is really on the services and getting information out from the truck and back to the driver or the fleet owner or the manufacturer. So what we did, we looked at what solutions are there and what alliances and communities are there working with automotive and infotainment systems. And we heard about some of those before. We have the MirrorLink, which is a use case that is very similar to Android Auto and Apple CarPlay. Basically, you bring your phone into a vehicle and you mirror the contents of that to the local system in the car. So those goes away, because what we are really looking at is this system in the car. We also looked at the Windows Automotive and the QNX, but for certain license issues and ownership of the solution and adaptability, we disregarded those as well. Of course, Linux is very attractive. That's an obvious one. Open source, attractive license model, and so on. The problem was, or is, actually, that we have so many initiatives and communities within Linux. And they're all looking at the problem or the challenge the wrong way. They're looking at it bottom up, very technology driven. Having worked with Bluetooth specification previously, I think they had the right approach, not looking at the deep technology, but rather look at it from the user. So in the Bluetooth community, you work with something called profiles that describe the end-to-end usage scenarios. So this is not what you're doing in Geneva and automotive-grade Linux, unfortunately. And these are also communities that have been around for several years, and there are hundreds of engineers spending time on this. So that went away. Left is something called AutoSAR, which is a kind of given standard within vehicles. So it's actually a software architecture for how devices on the CAN bus in the vehicle talk to each other. But we are not really interested in devices talking to each other. We want to have a user that is getting something graphical and can interact with the car. So that went away. So left is something called Android Open Source Project, which is the open source part of the Google Android solution, and the World Wide Web Consortium, the HTML web APIs that are getting more and more predominant. Android is a really good platform for World Wide Web and HTML5. So that's why we kept that. So the challenge now was, okay, how do we get Android to actually talk with a car? How do we integrate Android? Because that was not done. Android, as you know, has its base and foundation in mobile phones and tablets. And cars is not really the focus area of Google. So we found a sponsor called Vehicle ICT in Sweden and asked them to sponsor a project. And so what is Vehicle ICT? It's basically a community of large companies around Gothenburg that works within the automotive industry and that are trying to keep and foster innovation within automotive industry. So it's a government funded arena. So they founded this. And this is really interesting, I think. As I said, Geneva and automotive grade Linux, there are hundreds of engineers. They work for many years, and yeah, there are platforms out there, absolutely. We were 4 engineers working for 5 months and asked to do the same thing. So what we did is that we started with a community portal to make sure that we could, at least the 4 of us, because we were in 4 different cities in Sweden. So we had a community portal. We made sure that when we shared code, we had also this kind of continuous integration, building in quality in the system, and also having artifacts available for download. And everything in the system or the portal is based on open source then. So it's Redmine for the wiki and the backlog, it's Jenkins for continuous integration and so on. So this was a really good start. That was set up in less than 1 week. We had everything working, from the kind of discussions technology-wise to the code being integrated. And then in the end, we actually added a simulator to have real testing. And that's another really nice open source initiative that is called Torx. That is an open racing simulator that you can download for free. Then you can adopt it, which we did. So basically you have a steering wheel that you connect and you can drive in different cities. We connect it to a simulator that is for cars, and then you can feed your infotainment system with whatever you want to read from the car. So that was the kind of setup for this. And then, of course, we looked at, okay, how do you integrate Android to a vehicle? And this is a bit old architecture picture, but I think it was valid 1.5 years ago. Somehow, it's a different runtime today. Still have the binder and so on. So on top you have the applications, you have the application framework, you have the different libraries that are not in Java then, and you have the Linux kernel. So basically, this is what Android is, or Google is open sourcing. Before, we had a lot of applications in this domain as well. But more and more of those are moving up into the Google Play. So a lot of applications that you see today that usually have spent or had their repositories in the open source domain are moved up into to Google Play, unfortunately. Nevertheless, we looked at how the telephony manager was implemented, because that really separates the application interface from this kind of integrating the telephony functionality with the radio. So you have a separation from the application and the services from a telephony manager, from the actual radio interface layer integration to whatever modem you're using. So we did a copy-paste of that and created something called an Automotive manager. So you could get some services, and as an application you only cared about what services you are provided with. On the bottom we did signal integration to a vehicle interface layer. And we also provide kind of standard signals that, at least in the truck industry, is common between Scania and Volvo. That is called fleet management system. So typically, if you have an application, you get a certification from Volvo, for example. You provide that to the automotive service. The Volvo implements a policy management that tells you basically, can you read or write signals? What signals can you read and write to the vehicle? And once that's settled, you can access the signals. And then, in addition, the OEM can add whatever signals he wants that are kind of proprietary. And that's basically it. In addition, you can have hardware button control integration. For example, you want maybe a yes/no button or a home button. Increase and decrease volume, typically what you have on a phone today. And also, looking back at safety, we have this kind of driver abstraction that there is an ability to broadcast to all the applications that are communicating with the vehicle about the actual state of the car. So you can have a notion of maybe you shouldn't use your volumes too high, or you can dim the display and so on. But this is basically it. Separation, application. These are the new kind of services that are provided, and the OEM needs to do some integration into the actual car then. And that took 5 months to implement for guys. So that was a really good success story, I think. So now I talked about Android. Now we talk about the other part, that is not the device, but the cloud. So what do you adopt here, and how do you adapt it? And it's a mess. We will not go through it today. There is just very many things that you can adopt and adapt, and there is anything from Amazon services to Windows and protocols and languages. So you need to decide. You need to have a kind of thought about, how do I want to create my architecture? So what we have done is that we have taken our Android platform and integrated using MQTT, which is one of many different protocols. There are AMQP and XMPP and I don't know, all the things. The nice thing about this is that it supports this kind of microservices architecture. And I'm not sure if you're familiar with that, but it's a really nice way of creating architecture, that you you kind of split up the different services, and you have a kind of what do you call it? Publish, subscribe thinking. So you can publish data to a bus, and then you can subscribe to the data and do whatever you want with it. So the coloring here is actually kind of open source projects, Android. The service bus is implemented by Mosquito. We have a document database that is MongoDB. We have the front end based on Angular. And funny enough, we have Google here and we have Google there. So it's a Google-sponsored project, the Angular. And then we have created our own services. So we have microservices and we have backend services. We have the actual front end and so forth. And what is really, really nice with MQTT, why do you choose that? Because it's open source. Mosquito, as a kind of broker or service bus, is open source. And all the clients here, you can write that in Python, Java, C#, Java, whatever you want, JavaScript, because we have a service bus with a client implementations that is open source, and that's Paho that I really want to push for. It's a really nice project, and we're looking into how to contribute to this now. As you see, there are many different clients using this kind of architecture. So this is one way of creating an information of things system. Well, I have now talked about how you can reinvent the vehicle infotainment as not only being a DVD and FM radio player, and how you can think about not connecting things, but actually getting information out of things and using it in different perspectives. So this is why and what, and we talked about how you can do adoption and adaption of all these kind of software services. So I just want to give you a last minute of inspiration. What can you do when you have everything for free in open source? Open source, by the way, is not only software, so it's also hardware. So when we implemented this with Android and connected it to the car, basically ripping this out and putting this in, it's based on Arduino. So we have Arduino and Seduino, I think it's called. It's a CAN bus card that you connect to the Arduino, and then you have access to the car. Really nice. And then you can have some relay cards as well to talk with the blinkers and so on. So it's not only software that is open source. And then you can 3D print really nice things as well. There are things available that you can download and just modify slightly, and then you get a nice printout. So open source is good. So when you have that, you can go to a university and say that we have this platform that is free of use. You have students are doing projects of 8 weeks, learning different product methodologies like Scrum, for example. So what if we actually create something in 8 weeks when you're doing this kind of methodology thing? So we Volvo and Combitech had a discussion with Chalmers 1.5 years ago when we started the open source project initiative, and they directly saw the benefit. So the first course had almost 200 students doing this in 8 weeks with the simulator and the Android stuff. And it was amazing what you can create in 8 weeks with a group of 3 students. So there was actually a final on this one when the students could have a show and tell. What did they actually come up with? And the 3 teams that had the best ideas, they were invited to a innovation challenge, hackathon that Volvo sponsored this year in March, together with professional companies like Combitech and product companies. So they went into the competition on actually having the new kind of innovative services for Volvo to work on. And that was really fun to see what you can produce in 2 days. Yeah, as a bit of inspiration, how you can actually use open source and IoT to create new fun stuff. Okay. Thank you.